Okay, this is a short lesson on how to do the calculations portion of the flame test lab. You should have by now have all the colors of the flames, and you have looked onto the color spectrum and determined what the wavelength was in nanometers. I'm going to just do one as an example. I'm just going to make up a number. Let's say one of your metals gave off a color that you deemed the wavelength to be 500 nanometers. There's the symbol for wavelength. Now, you've got to go calculate frequency. There is one equation that will allow you to do that. That's the C equals wavelength times frequency. All you need to do is divide C by wavelength to get the frequency. Now here's the little trick though. The wavelength is in nanometers. C is in meters, so we have to do a quick conversion. Take the 500 nanometers and divide by 10 to the 9th nanometers to 1 meter. That's how many nanometers are in a meter. Kind of like 100 centimeters is in a meter. This is how many nanos are in a meter. When I divide this, I get 5 times 10 to the minus 7th meters. That's going to go there. And that's going to help us get the frequency. So C is 3 times 10 to the 8th. We're going to divide by 5 times 10 to the minus 7th. Do that in parentheses. You should get 6 times 10 to the 14th. This is frequency in hertz. Now, you've got something that's going to go there. That's how you get that column right there from that wavelength. Now let's go find energy. Energy is found by multiplying Planck's constant with the frequency you just calculated. Now Planck's constant is 6.626 times 10 to the minus 34th. Multiply it to the frequency you just calculated. When you multiply these two together, you should get 3.98 times 10 to the minus 47th. That comes out in joules. That's what goes here under the energy. So this is a short lesson. I hope this was helpful in showing you how to go from the wavelength to the frequency to the energy.